Okay, let us discuss problem 1.270. So this is something related to finding angle. So let me read the question. So this says a conical pendulum, a thin uniform rod of length L and mass M, rotates uniformly about a vertical axis with angular velocity omega. The upper end of rod is hinged. Okay, so this is the vertical axis you have, and there is a rod, and the length of this rod is L and the mass of this rod is M, and let us say this makes an angle theta with the vertical, and this rod is hinged at upper point. Let us call this point as A, this point is B. So basically rod is hinged at point A. Are you getting? This means there is free rotation about A. So there is no torque that is acting, there is no moment that is acting about A. So I can say torque about A is 0 because this is a hinge, and hinge has a property that it cannot apply any torque. So torque about A is 0. That is the free rotation about A is permissible. So free rotation about A. Are you getting? Now let me see to read the question more. So thin uniform rod length L and mass M rotates uniformly with angular velocity omega. Find the theta between rod and the vertical. So this rod is basically rotating with angular velocity omega about this vertical axis. We have to find theta. So what is the theta? Find theta. Now if you see any point of rod, let us say even consider this point is moving in a circle. So this will be the circle in which this point is moving. If we consider any point of circle, it is moving in the any point on the rod, it is moving in the circle. Now why this rod is in equilibrium? So if you see this rod is in equilibrium, making angle theta. Why this angle is inclined? Why this rod is inclined? Because you see there are two forces that is acting. At the center of mass you will have a force that is mg that will act. And now if you consider any part, there is a pseudo force that is acting also, or you can say centrifugal force. This rod on this rod, at any point there is a centrifugal force that is acting in this direction. Because any point, so this is moving in this circle, let us say this length is x. So if I consider a dx part, I can make another diagram. You can use the same diagram if you wish. Let us consider at length x a small part of the rod, that is dx. So this part of the rod I am considering. There is a force that will act, so this part is moving in this circle. So if this length is x, this is theta. Now you know what will be this length. This is x sine theta. This is x cos theta. This is x sine theta. So radius of the circle is x sine theta. Are you getting? Now you will have a centrifugal force that will act outward, m omega square x. Mass of this is, so let us say m is the total mass, so mass per unit length is m by L into dx, that is the mass of this small part, into omega square into x. X is a radius basically. You can say this is the radius, m omega square r you can write if you have any confusion. So this is m omega square r, and r is x sine theta. So this is the centrifugal force that is acting. Now what I am going to make is, This rod is in equilibrium about this point. So what I will do is, there is a two torque. One torque, that is mg. So mg tries to rotate this rod this side, and centrifugal force try to rotate rod this side. So what will happen? Equilibrium will be reached, and torque due to mg should be equals to torque due to centrifugal force. So what is my target is to find torque due to centrifugal force first. So now I am interested in finding torque due to centrifugal force about A. Are you getting? Now see, this is the centrifugal force I have already calculated. So centrifugal force is m by L dx omega square x sin theta. This is the centrifugal force, and this is the force, and this is the distance, perpendicular distance, that is x sin theta. So torque will be force into this distance is x cos theta, f into x cos theta, and this is the value of f, a small force you can say. Are you getting? So a small movement, that is, let us say d tau, this will be equals to m by L into dx into omega square x sin theta, and then I have to multiply by x cos theta. So this is the small moment that is acting on the rod due to point A. So I can also write d tau is m by L omega square, this is x here, so we will have x square sin theta cos theta I will have, and then into dx. So I can write m omega square, let us put 2L and multiply by 2 on the top, so we will have 2 sin theta cos theta, that is sin 2 theta into x square dx. I have to integrate 0 to L, so I will have m omega square by 2L sin 2 theta x q by 3, that is L q by 3. So this is the torque of centrifugal force. Now I have to find torque about A. So this is the torque about due to centrifugal force. This is the total integration. So if I do this side integration, so this is a small torque will be total torque. Now torque due to weight. So let us find torque due to weight. Torque due to mg. So what will be this torque? I think all of you can find this torque. This is easy. So let us find this torque. Until now, those who have not written, copy this one. So you see, torque due to mg will act in the middle, that this distance will be L by 2. Are you getting or not? So if this distance is L by 2, I have to find this distance, because mg into this distance will give torque this side. So mg into this distance, so this distance is L by 2, this distance will be L by 2 sin theta. So torque will be mg into L by 2 sin theta. Now these two torque has to be equal. So this torque, one torque is clockwise, another torque is anti-clockwise. So at equilibrium, these two torque has to be equal. So if I equate these two torque, mg into L by 2 sin theta, this is equals to m omega square by 2L. Let us put sin 2 theta is sin theta cos theta, so 2 goes out, so I can write, because I can able to cancel this one, sin theta cos theta. I have written sin 2 theta is sin theta cos theta into 2 I have cancelled the 2, L q by 3. So you see, sin theta goes out, m goes out, we will have 1L and 1L, so we will have 2L that is goes out, so this side L, so we will have simply 1L this side. Are you getting or not? So what we will have, you will have 3 by 2 is equals to, so let me write, so you just copy this one, you can solve for yourself. So it will come out to be cos theta is equals, if you solve this line, finally it will come cos theta is equals to 3z divided by 2 omega square L. Are you getting or not? Let us try to find this value. That is, cos theta will come out to be 3z by 2 omega square L. So you see, this is the same thing, 3 by 2, and L goes, so you will have only one L this side. So L will come downside and omega square will also come downside. So you will have 3z by 2 omega square L. So this is the equilibrium angle. So theta will be given, or cos theta will be given by this. So in equilibrium, this rod will make an angle cos theta that is equals to 3z by 2 omega square L with the vertical. Are you getting? So you see, this problem covers the concept of a torque of pseudo force. Now you see, centripetal force, that is basically pseudo force, m omega square x. I am taking torque of this pseudo force. Torque of this pseudo force has to be equal to torque of mg, because this pseudo force is acting away from, it try to increase the angle, but mg tries to decrease the angle, and that's why there is equilibrium. That's why there is a theta. For that theta, the both torque is equal. Initially, if you increase the omega, centrifugal force will increase, because m omega square x, centrifugal force will increase m omega square x. So centrifugal torque will increase. So if you increase omega, the theta will increase. You can see from here itself, the last result, you see, cos theta is 3. So if you increase omega, this value will decrease, so cos theta will decrease. This means theta has to increase, because cos theta is a decreasing function. One can also see, if you increase L, this cos theta decreases, this means theta increases. So if you have a larger rod, you will achieve equilibrium at larger theta. That is obvious, because in that case, moment of the pseudo force, moment of the centrifugal force will increase. Now we'll discuss the next problem. I think all of you have copied this one. This is a pretty easy problem, but good problem. Let us go for the next problem.